Welcome to part 2 of our quest to build a real-life functional plasma pistol from the video game Halo. Dude, that was amazing! Just like the game, we want our plasma pistol to shoot individual shots of green flaming projectiles. And if you hold down the trigger, it's gonna shoot one massive blast. If you haven't seen part 1, go check it out to see the physical plasma pistol take shape. With our friends at PCBWay and Prusa, we utilized metal 3D printing for the frame and incredible quality FDM 3D printing for the non-structural parts. And now that we have something that looks like this, it's time to figure out how to make it go like this. So our pistol here functions much like a miniature black powder cannon, starting with a spark that ignites a charge and shoots a projectile out of the front of the barrel. Now imagine this concept but times 10. 10 shots in 10 barrels in one barrel assembly. But instead of a cannonball, we will be shooting bright green pyrotechnic stars. I'm dedicated to making this plasma pistol work, no matter what, because this is the test bed for our next project, the plasma rifle. And to make this project that much cooler, we have 2 brilliant electrical engineers working on this with me, Mikey and Drew. And together, we came up with a way to trigger each shot using actual plasma. Drew is gonna design a custom PCB to make all of this work, and my brother Mikey is on software duty. And once that board was designed, we reached out to our friends at PCBWay. They agreed to help take Drew's design and turn it into an actual physical board. And a few clicks later, the finished boards were delivered in a box to my doorstep.
Ooh, that looks good.
It fits perfectly. All right.
You want some cables? Here we go.
I think it's gonna be successful, just based on this.
So we're here in Kansas City. We've got the dream team here, Ryan, Drew, and Mikey. Today we're gonna make this thing actually work. We've been working on this project for virtually forever, since like September of 2024. And I couldn't wait for these guys to hold the plasma pistol for the very first time.
The paint turned out really good on this, actually. And I see you have a nice little insulated area so we don't get shocked here. Hopefully that holds up.
Jeez, this is heavy.
Hey.
This is really, really cool. Can't wait to see it shoot.
So this here is going to be the microcontroller that Mikey is programming. That's going to send these little signals to our switches right here to power our transformer here.
And that is the concept. These are our plasma lighters.
Good.
It does work.
Whoa! What we need to do is make 10 of these on one board. We got a bunch of circuits on here, as you can see, 5 and 5, and we just need to take the transformer from this and put it on here, and it should work.
I guess that's a transformer, the most unelectronic thing here, but this is nerve-wracking here. You know, like pull this thing apart, like while it's powered on.
Oh, yeah, make sure that you don't spark yourself.
So while they're working on that, I'm gonna be working on the barrels. Okay, that's how they come apart right here. I'm going to be putting some wires through these holes right there, and they're gonna come pop out of the back, go into these connectors down here, and into the board. They have something ready here to test.
A little button as well as a transformer here, and we're gonna hope this works. 3, 2, 1.
Let's go!
Never doubted it, one bit.
Oh, it's gonna work. We got one circuit completely working, from board to MOSFET to transformer to connector to barrels. And that's a massive win. It's all been concept up to now.
And now it's
Alright, next transformer!
So what he doesn't know is we got 10 more of these going together. And who knows, all 10 of these may not work together.
What he doesn't know is, while Drew attaches the rest of the transformers, this is how Mikey plans to program the individual shots.
So picture a line, a queue of people, where the first person steps out of the line, does something, and then gets it to the back of the line again. So that's how we actually do this. For each individual barrel, it's a person in this line. They step out, activate, they shoot, and then they get back in line. So every time you press the trigger, it just circles the line. It's called a circular queue.
And for the one big blast,
Whenever you hold down the trigger, we are recording how long it is being held. So whenever you release it, like in the game, we say, hey, it's been held for 5 seconds. We're gonna shoot all of the barrels.
So I just finished putting together all 10 transformers.
For me, I uncommented some code and I'm uploading it now.
for me, I'm attaching all of the leads from the barrel assembly to these connectors.
And for me, I'm filming it.
Yeah, it's the most important part! Leads.
Yeah, and hopefully our mess of transformers here will not short out to each other, but we'll see. Yeah, you can power it on if you want.
Okay.
Oh,
3
turn it off,
volts.
turn it off.
That's shorted.
Wait, what just happened?
I turned on the power supply and it's set to be at 8 volts. It dropped to 3 volts, which means that there's something wrong. Power went somewhere.
So potentially 2 bad MOSFETs there.
You could try checking the resolution on the flange crystal fibrillation. Did you try that? Up the joules by
He has a good point.
2. Thank you, Mikey.
When you actuate one of these transformers, but the leads aren't close enough to make an arc, that energy has to go somewhere. And right now, it's going directly back into the board, frying components. So to fix that, Drew created something called a snubber circuit. When we test this out next, if there's any energy going back into the board, the snubber circuit will catch it before it destroys anything. Drew's doing all the work right now. Good job, Drew!
This project seems to be really one-sided. All the new MOSFETs are on, all the transformers are on, the new circuit to make sure get rid of all that dissipated energy we talked about. So we're gonna hook it up to power and basically see if anything's wrong. System on.
Nice.
That was so cool.
Nice! The snubber circuit is working just like it should, and we have 10 of the transformers firing. Now it's time for our very first live fire test. We're going to test how long the plasma has to be on to ignite our charges. I'm not gonna put too much black powder in here, just enough to ignite it, right? I don't wanna blow my dad's garage door off.
I feel prepared. This will put out any fires and also serve to whack Brad over the head for doing something dumb.
A massive shout out to RTS Tactical for sending us bulletproof vests. I mean, we've been doing some crazy stuff over the years and we probably should be safer, and this is definitely gonna help us with that. We've got an affiliate link in the description. Check them out if you want a bulletproof vest.
Probably not gonna work the first time. That's a good thing, because we then can step it up to where it works.
Yeah. Good plan. All right. 3, 2, 1.
Oh! 100 milliseconds was enough.
That worked.
That was awesome.
That was really cool.
That was 100 milliseconds.
100 milliseconds will do it. At this point in the project, we were feeling pretty good about the progress we were making.
This is the channel you're looking for. Like and subscribe.
But then we ran into a really big issue.
Turn it on, Mikey.
Yeah.
So currently right now, when we turn it on, we get a spark, and that will not be good for in the future when we turn on the gun, we actually have powder inside, and that's a huge safety issue.
Yeah, that's not good. But I'm pretty confident that Drew can figure it out. So, the consensus here is that we need to do a couple things. First, Mikey and Drew are convinced that the computer is the reason for the spontaneous ignition, so we want to try a different one of those. Second, we need to add something called a safety circuit, which will prevent the transformers from spontaneously firing. And third, there are also random shorts that keep happening that we think are due to all these exposed wires from everything we've added to this board so far. So adding all that up, as much as I hate to say it, the right thing to do is design a whole new board. That includes all of these things.
As engineering projects go, there's always problems, and it always takes longer than you expect.
And sadly, that means that we're going home empty-handed today. Really appreciate you guys working on this, for real.
It's a tight spot because I think right now, short term, yes, we don't have anything. So it's just a matter of getting this circuit board figured out, which will happen. We just don't know how long, but it will happen, and then we'll get to shoot this pistol at some point.
Thank you for not be trying to publish this video tomorrow.
Okay, so it is now May 30th, so it's been a month and a half. Mikey just sent me a text, and we finally have the new boards. They're blue this time. Drew is gonna start getting to work again on this board. We'll give you some updates as we go. How about that? Now, I got some pretty cool filaments from my friends at Prusa, and I told them I was using PLA for these barrels, and they said, we have some better material that you should probably try. We're gonna test ASA Jet Black. All right, so we got the printer moved out to the garage. There's a lot of fumes that come with ASA. So the garage door's open, it's a 5-hour print, just leave the garage door open, let it go. Part 2. Wow, these parts look freaking great. This is ASA, and apparently this stuff is a lot more durable than the PLA, and also fire resistant. And I really appreciate Prusa for sponsoring this project. Using this Core 1 has been an absolute game changer. What used to take me a few weeks of sanding now takes me just a few days to fill in the print lines, thanks to these parts having impeccable quality. If you want the best 3D printer on the market, go with a Core 1. So yeah, thanks Prusa for sending the ASA and also the Core 1, and they also sent me an original Prusa XL. We'll be using that on the plasma rifle, don't worry. We've got a lot more stuff to come with our friends at Prusa. So thanks again to Prusa for sponsoring this video. Okay, it is July 17th. And I just got a text from Drew and Mikey saying that the circuit is done. Hopefully Mikey did a little bit of picture taking or filming or something. If he did, we're gonna show it now.
The board's good. It has safety circuits on it now. It should be solid.
Have you tried it with a battery?
No. But I don't think that's gonna be a problem at all.
So, with everything working, Drew and Mikey boxed up the board and shipped it to me to finish. We finally got it. The board is here. Wow. Come on. There it is. This is like 3 months of work. Holy cow. It's not plug and play. There's a couple things that I have to add. You know, there was a point a couple months ago where I was like, is this really gonna work? But we're here, and I can finally resume this project. Thank you, Drew and Mikey. You guys are the real ones. I got everything wired up. The 2 battery leads with a fuse and an on and off switch, a safety, and the trigger. I'm scared. I want to turn it on. I feel like I gotta turn it on. I'm gonna turn it on. I gotta turn it on. I'm gonna turn it on. I'm really nervous. Okay. It didn't do it. Is there any heat? No heat. And I think I blew a fuse.
It shouldn't draw 10 amps, definitely when you're not, like, you know, arcing.
I have a 15 amp fuse here. Look at the light, look at the light.
Yeah, I see.
Ooh! I just fried something. Oh! We got a short on the board. How did that happen?
That's a probably send back to us thing.
This video, man. I just wanted to work so bad. Sitting here looking at this thing, it's like, I'm afraid I'm gonna do more damage. Oh God. I gotta make a trip to Kansas City. I gotta make another trip to Kansas City.
We're gonna need Drew to replace things.
I promised at the beginning of this video that plasma pistol is gonna be working at the end of this video. If I leave Kansas City tomorrow without the plasma pistol working, that's gonna be probably gonna mean more months of work. That's kind of where we're at. Just thank you guys for watching. I really appreciate it. This is what it's gonna take to make a real life plasma pistol. All right, we're here.
All right, it's time to watch Drew do things.
Yes.
I will provide the beer.
Yes. Did they all just die on us? There's a good chance, actually.
You want to just build up a whole new board real quick? It may be faster.
Okay, look, partial built up board.
So this is board number 2 in the trash. Transformers are officially off. Whole new board.
It's really like doing surgery, you know? Okay, that one's in the right direction.
We got a clove of garlic or scale.
This is the capacitor I've been putting on. And then this is the diode that I'm gonna put on now.
My
Brain surgeon.
brain surgeon.
Yes. What we want to see is this light turn on, and that tells us if it's working or not.
Hey!
Let's go!
Okay. So we're about to do this exact same test that I did and it smoked last time, okay?
If we turn on, should see the light. Let's go. We haven't done the safety circuit yet. Oh, let's make sure it didn't turn on. What the heck? How many volts is this? What size battery do you get?
What do you mean what size battery did I get?
I designed it for 8
Is it not 8 volts? 3.8 for each one.
per cell. There's 2 cells.
No.
In this battery.
I thought each one of these batteries was 3.8 volts.
So
I put double the amount of volts through this.
Yeah.
Oh, that's why I blew up. Like, we're gonna have to pick this up in the morning.
sounds good. 10 a.m. ish.
Well, we stayed up till 3 a.m. last night.
We're back again at the gang's house, looking at debugging this thing.
First things first. McDonald's order.
Because Drew didn't press the safety switch with that 16 volts from last night, hopefully all we need to do is just plug in 1 battery, and it should work.
There you go.
Green light.
And
Let's go.
Oh, this is so satisfying.
Now we just have to hook up the transformers, make sure.
Oh my God, it's happening. So Drew installed all 10 transformers, and then we were ready for our first fire test of this new board.
This is reliably working.
hey, look how fast it goes.
Oh my goodness. And it's all on this battery. We just toggle through 10 with the battery, and that's it.
Hold it down.
Oh, we do have to test that, don't we?
8, 9, 10.
That's a freaking working board.
There you go.
Holy cow. All right. See you, Drew.
Yep, see ya.
See you, buddy. Thank you.
You're welcome.
So long.
Farewell until we break a MOSFET again. Okay, back to Tulsa.
Pretty cool. I know a lot of hard work went into that thing.
I got back from Kansas City late last night. I got up in the morning and I plugged it all in and started testing. Boom, 1 MOSFET dies. And then boom, another MOSFET dies. I take that one off and then boom, another MOSFET dies. I'm blowing components, and there has to be an underlying reason why these components keep on blowing. And that's been a consistent problem that we've had over this entire project. I don't know enough about electrical engineering to troubleshoot this problem, but I did promise you guys something at the end of last video, and that was at the end of this video, we would have this thing shooting. As you can tell, we're nearing the end of this video, so here's the plan. I'm gonna put all this together, I'm gonna put it inside the plasma pistol, get everything back into working order, and then tomorrow, we're gonna go out and try it. If it blows a couple components, it blows a couple of components. My goal is to get some shots off, but I don't know if it's gonna blow it after a couple shots or maybe after 30 or 60. I just don't know, but I feel like I owe it to you guys to give it a shot. And if it doesn't work, you know, it doesn't work, but if it does, it's gonna look really cool, and it will be a taste of what this project will be when it's completely functional and reliable. And trust me, we're not gonna stop until this thing works, and it works really well, because the plasma pistol is really only part one of this entire thing. We're planning on scaling this to a plasma rifle. I've already got the parts built. I'm not gonna show you too much of that. And just imagine 3 of these and full auto, right? So we gotta figure this problem out so we can use this whole idea to scale for 30 shots for the plasma rifle. Turn it on, safety switch. No short. Fire in 3, 2, 1. 6, 7, 8, 9, 10. There we go. Oh, 9 out of 10 are working right now. Not optimized, but it all fits. Once I have the leads on the barrels, I think we're ready to test. At the end of this day, we're gonna be shooting this plasma pistol. I ran each wire through the barrel assembly, bolted everything down, and somehow everything is still working. And with that, it was finally time to shoot our plasma pistol for the very first time.
Have you ever hurt me? Because it might happen today. I'm just realizing this.
So we're here out in the middle of nowhere at Sean's house. Thanks for Sean for letting us have us out here.
You're picking all this up.
Proof of concept, let's shoot this thing, and maybe, just maybe at the end of it, we'll test the big shot, hold it down, shoot all of them at the same time. There's still a problem with the board, and it's gonna fry these MOSFETs. So we're gonna shoot it until it shorts. I 3D printed a little funnel here to help me out with this, and I have little 3D printed scoops. I really don't know how much black powder we should put in. That's a lot.
We will see.
Definitely too much.
Oh my gosh, it filled the entire thing.
Yeah, that's way too much. All right. Okay. Didn't come out. We might have to blow. We might have to shoot this.
Burn it off.
You want to?
Yeah.
All right, on 3, 2, 1.
Oh, it's so loud. Why was it so freaking loud?
We're okay. I'm shaking. That was amazing. That was insane.
Dude, let's load it. This is awesome.
I'm gonna put a bulletproof vest on for this. That initial test shot, so loud. Let's just do this. Hey, we got Master Chief here too. Hopefully it won't break and you'll get to shoot it. All right, here's the first test of the real life plasma pistol with some sick loads in it. Power's on, safety switch is on. We're live.
Let's go.
Fire in 3, 2, 1. Oh, that was anticlimactic. Okay, let's give it another shot. Oh my God. Holy crap, I'm gonna turn that off. Are we okay? Yeah, the plasma pistol just blew up in my hands. And somehow I'm not hurt. Holy cow, that was did you get that? You got all that?
Got all that.
Did you get that, Chief? That was close. I want to see what that looked like. On one of the first couple shots, the barrels came loose a little bit and let all the black powder fall back. It lit the whole thing and boom. Wow. Created a bomb. Thank God we designed this out of metal. We definitely overloaded the shots. Well, now we know.
Now I think load it more.
Luckily, I have more of these barrels, so I say we load it back up and give it more shots. Okay, round 2, test 2, less loads, new barrel assembly. Chief, I think it's time for you to shoot the plasma pistol. Power switch is on, safety switch is on. Fire in 3, 2, 1, fire! Yeah! Dude, that was amazing.
I was standing out there and having him go by. It's like,
guys, we did it. It works and it looks amazing. And somehow it didn't break. That feels so good.
and no fire safety required.
Yep. Feel a little left out. Before we call it a day, we have one more round of shots to do. Ryan, you want to take this one?
If I shoot it, Brad, I'm just saying my finger might slip. I might hold on to it for a while, and when I let go, all 10 go off.
I might be okay with that. Everybody ready?
Ready. 8, 9, 10.
Nothing?
Oh, I gotta let go.
Yeah.
Here we go. Dude. That was so sick. That was a plasma pistol. I want to do it. Like, I want to do it again. I want to feel like in control. I forgot it. I was like waiting for it to go off. I was like, oh dang. Oh yeah, I gotta let go. Boom! Oh, that was so cool.
How'd it look from your side?
Whoa! You got the shot right there.
Holy crap. up.
So cool, man. I think I'm gonna hold on to this one.
We got a working plasma pistol, guys. I'm so happy. But I hope you're not satisfied because neither am I. There's a lot more tweaking that we need to do before we can actually take this gun through the paces. Somehow, these MOSFETs didn't break. I need to be changing some capacitors and some resistors, 100%. We need to get it optimized so we can use this design for a plasma rifle. That's what's next on the list. 3 of these boards together in a series, full auto, 30 shots. It's gonna be freaking awesome. So in part 3 of this series, that's right, we're making 3 of these videos. Once this thing is reliable, we're gonna be putting the plasma pistol through the paces to make sure that it is. We've got all kinds of plans for this pistol and you're gonna love it. So thank you guys for watching. If you like this video, there's a playlist right here of all the other Halo weapons that we've shot. So check it out and we'll see you guys in the next video.
We built this!
Yes, sir.
Yeah!